Rectifiers. What is the main purpose of these rectifiers? They are mainly used to convert AC signal into DC. The main purpose to convert AC signal into DC signal. Why do we convert AC signal into DC signal? There are so many electronic appliances which operate with DC power supply, like your mobile, laptop, okay, some electronic devices. They operate, some examples, as an example I am saying, they operate with DC power supplies. Okay, and one more thing, one more advantage of converting AC into DC is we can see the inverters at our home. If you take an inverter, what does it do? Okay, as long as the AC main power is on, then all the electrical appliances will be operating with the help of that AC power. But once the AC power is off, then how do they work? Means with the help of this inverter. What this inverter do? What does this inverter do? Means here, first of all, it converts the AC signal into DC signal and stores that DC energy in a condenser. And whenever the power is lost, immediately the DC is converted back into AC, and that AC is connected to all the electrical appliances at our home, which will be running without any interruption. That is one more application where we are converting AC into DC. Of course, two things are happening here, AC to DC, again DC to AC. Two things are possible in inverter. But these are some of the areas where we convert AC signal into DC signal. Then let us have a look at the basic block diagram of the system which converts AC into DC. See this. Here 230 volts line, right? Okay, it's an AC line from the mains, and it is a 230 volts RMS value. It is mentioned 50 hertz, 230 volts, 50 hertz signal, and the 230 volts here is RMS value. Please do observe this. This is given as at the primary winding of the step down transformer, and output of the step down transformer is also an AC signal. This is V secondary. It is also an AC signal. And generally the turns ratio is 20 to 1 or 10 to 1. We can see the turns ratio of the step down transformer. Next, the very first stage of this system is diode rectifier, right? It may be a half wave or full wave rectifier. What does it do? Means the secondary voltage is a pure AC signal. The secondary voltage is pure AC signal, and it's a bipolar. The rectifier converts this AC signal into unipolar, or it converts bipolar to unipolar. The output of a diode rectifier is either this way or this way. It is unipolar signal, I can say. Okay, here the average value, it is pure AC, I can say, secondary voltage, and here it is not AC, it is a non-sinusoidal signal. According to Fourier series, we can express it as a sum of DC component and AC component. Fourier series expansion and all. DC means it's an average value. Well, right, it is okay, it's a combination of AC and DC. We will see all those things further. So first you converted this bipolar signal into unipolar, which has some DC, and to extract that DC we are using a filter. And what kind of filter it might be? The filter should be a low pass filter. Why it is low pass filter? We are expecting a DC signal that is the best possible low frequency signal. The frequency of DC signal is 0. I am expecting the best possible low frequency signal. If you take a low pass filter whose frequency response is like this, the gain versus frequency, if you take, it is allowing all frequencies from 0 to FH. it has some upper cutoff frequency within that frequency range, and I am using here a low pass filter with a very low bandwidth. The bandwidth is as much small as possible, so that it gives the best possible DC at the output, so that we can suppress the AC component, unwanted AC. This XAC of T I wrote now, it is unwanted AC signal, also known as ripple signal. To remove the unwanted AC or ripple signal, we are using here a low pass filter. So that what comes at the output of the low pass filter, it is a variable DC, it is not pure DC. I can say the output of this one is a variable DC. Variable DC in the sense, okay, this is the right here. What do we get means this part we can see here, okay. And what is possible here? It is a variable DC, means it is coming something like this. You see how the shape of the AC signal is changing after passing through various stages. The first it is like this, next it may be either this or this waveform, and after passing through the diode rectifier, next a low pass filter, so that it looks something like this, a variable DC. Okay, and still it has some variations in the signal. DC signal means it should have constant amplitude. To have that kind of waveform, we are using here the next stage as voltage regulator. What is the output of this voltage regulator? Means we can see a constant DC. A regulator produces constant output voltage independent of variations in its input. Its input means like this one, and independent of variations in the load resistor. The load value may be 10 ohms or 100 ohms or 1K or 1 mega, whatever it is, independent of the load, right? Generally what we expect, when a resistor is changing, voltage across that particular resistor changes. That is the general thinking we have, but here it will not happen. So we will see how it is. Okay, just this is overview and introduction to our rectifier system. So it maintains a constant output voltage, right? Regulator, what does it do? Means it gives a constant output voltage independent of variations in the input and independent of variations in the load resistor. Its input may vary, or the load resistor may vary, but its output, final output, does not vary with respect to time. It has some amplitude A, I can say. A perfect DC we can achieve. These are the various stages involved in converting AC signal into DC signal. The rectifier itself cannot convert AC into DC, and the output of a rectifier is known as pulsating DC. We can also know it is also known as pulsating DC. Okay, that's it. These are the various things. Then before going to our rectifiers, or we will say all those things, here what I do is, first I take the transformer, step down transformer with diode rectifier, maybe half wave or full wave rectifier. Next I connect the load resistor here. We analyze the circuits, how this kind of waveforms are coming, so that we calculate some parameters like average value, RMS value, ripple factor, peak factor, percentage regulation, efficiency, transformer utilization factor, right? All such like that. And every parameter has its own significance. What is its significance and what should be its value? We will check it. Next, along with step down transformer and diode rectifier, instead of taking the load resistor here, I will connect it after the load resistor. So here some load resistor is connected, so that how the filter is eliminating the unwanted ripples and gives almost a DC signal, a variable DC. We will be analyzing capacitive filter, inductive filter, like that. We have some parameters, some circuits. Next, that is the second case. Next, instead of connecting RL after the filter, we will connect after the voltage regulator, means this is our load. So how the regulator is giving a constant output voltage independent of variations in the input and independent of variations in the load resistor value. We will check that as well. These are the various things. Again, before going to our rectifiers, we just discuss some points like the significance of average value. Suppose I have a signal x of t. What is the significance of its average value or a DC component of x of t? And what about the RMS value of x of t? What is its significance? And the ripple factor, okay, and loading effect. What is meant by loading effect? All these things I will be discussing first. Then once you are ready with this groundwork, some basic terminology, even though most of you may be aware of it, but how to connect them to our analog circuits. That's what my concern is. So in that context, how do we define them and use them? According to our uses, I just make some changes. No basic definition changes, but the way in which I explain will be a bit different compared to what you study regularly. Okay, that is a small difference. Just to link it with our analog, nothing else. Okay, so let us have a look at these things first. Okay, suppose I have a signal x of t, some AC signal. Something like this, and its period is capital T. This is 2t and 3t, like this. Okay, I have some signal. It is a non-sinusoidal signal. Whenever you have a non-sinusoidal signal which can be expressed as a combination of DC and AC according to Fourier series. We are all well aware of it. Okay, and here I am writing x DC. DC, or it is also known as average value. Okay, anyway, right, we generally write x DC is equal to 1 by t integral 0 to t x of t dt. We are well aware of it, basic Fourier series formulas and all. And x AC, right, it can be written like, right, or it is also known as a naught plus sigma n is equal to 1 to infinite a n cos n omega naught t plus sigma n is equal to 1 to infinite b n sin n omega naught t, like this. And a naught is the DC term which is a constant value, and this is about the AC term, in which DC or a naught or x DC, it is given by this formula, and a n is given by 2 by t integral 0 to t x of t cos n omega naught t dt, and bn is equal to 2 by t integral 0 to t x of t sin n omega naught t dt. We are well aware of all these formulas and all. Let it be. Okay, so here x naught, it is a DC term. We know it. Again, what is meant by DC? It is also known as average value. What is the significance of this average value of a signal? The signal need not be like this. It can be a sine wave or a triangular wave or a square wave. Anything is possible. For any signal, this is what we can write: a naught, a n and b n values according to Fourier series expansion. So here, what is meant by average or DC value? Okay, what is its significance? Best example, average value. Suppose you take a classroom which contains 60 students. The best example I can take. Then what is the average mark of the particular of all the students in a particular subject? I would like to write it. Suppose mathematics, one subject is there. In that, out of 60 students, right, if I take the marks for 100, right, what is the average percentage, average mark of the class? I would like to see. What we do, we take all the 60 students, 1, 2, 3, 4, etc. 60. For each one, how many marks? Suppose he got some 92 marks and he got some 68 marks, he got some 54 marks and he got around 99 marks, like that, and he got around 76 marks, like different people are having different marks. Then what do? Simply we add up all the marks, sum of the marks, average mark. It is equal to sum of all marks by the sum of number of students. Is it not so? Or sum of the students we write it. Okay, if it is a discrete, we write sum of marks by the number of students, sum of students. If it is discrete, this is what we do. If it is continuous, then see, suppose in a class the marks of the students are varying like this way. Anyway, there is an university which is giving negative marks. Of course, it is tough. If you give positive marks itself, students are not maintaining good percentages. If they give negative marks, where it goes, we can't imagine. Let it be. Just as an example I am speaking. So, in a class, the student marks are like this. Now, I want the average percentage, average mark. What do we do? If it is discrete, we are adding, we are taking the summation. As it is continuous, we need to take the integration. So, integrating the signal x of t over one period. No need to worry about taking from t is equal to 0 to infinite, over one period. Whatever I have from 0 to t, the same thing is repeating from 2 to tt, 2t to 3t, etc. So 0 to t. Summation by, instead of taking discrete samples, the number of students, I am taking the total period. Very simple. That gives us the average amplitude of the signal. That's it. Or that's the meaning of it. X DC or X average is equal to, so DC signal or X average amplitude of the signal, it is given by 1 by t integral 0 to t x of t dt. What is the average amplitude of the signal? We wrote it. That's the meaning of it. Okay, average amplitude. It may have different amplitudes at different instants, out of which you are bringing the average amplitude of the signal. Okay, fine. This is the basic meaning of it. Done. Next, if I have a perfect sine wave like this, what is the average amplitude? It is like some a sine omega t. I am writing. Then, or a, instead of a, let me write Vm otherwise. Anything we can write, it can be a voltage or current, anything is possible. Vm sine omega t. Then average amplitude means it is also known as written like area by time period. Is it not so? Just by observation, we can take the area is 0. Right? If I take this particular portion, this is A1 and this is A2. So, what is the relation between A1 and A2? A1 is equal to minus A2. So, total area, apt meaning means total area. What is the total area? A1 plus A2, in which A2 is equal to minus A1, ultimately it is 0. But it has some time period, no doubt about it. So, its average value, average amplitude is equal to total area A1 plus A2 by time period. A1 is equal to minus A2, right, by t, it is simply 0. Average amplitude is 0 as far as this signal is concerned. Average amplitude is 0 means now I can say this is a pure AC in the sense it doesn't contain any DC term in it. Very simple meaning. Okay. Instead of this, suppose I have a signal like this, x of t, 0 to it is a T by 2 and a capital T, it is repeating something like this. I have some signal like this. I can express it this one also a combination of DC and AC. Okay. What is its average amplitude? Okay. Average amplitude means in a class the marks of the students are varying like this. The same thing is repeating here. So average amplitude I would like to find. It is given like it is Vm. Then x of t is equal to Vm sine omega t over the interval 0 to t by 2. I can take it so. Next, it is equal to 0 from t by 2 to t. Okay. Then what is its average amplitude? Once I know the definition of the signal x of t over one period, I can find its average amplitude. It is 1 by t integral 0 to t x of t dt. It is equal to 1 by t integral 0 to t by 2. It is Vm sine omega t, and again from t by 2 to t it is 0. That's the definition. Next, further it is 1 by t. I can write Vm by t. Anyway, this term is 0. So Vm is taken outside the integration. Sin omega t, its derivative, sorry, its integration is cos omega t by omega with negative sign over the interval 0 to t by 2. Further, it is minus Vm by t into omega, and here I can write cos omega t by 2 minus cos 0. I am substituting the limits. And we know that t is equal to 2 pi by omega, or t into omega is equal to 2 pi. We are well aware of it. So that what we can write, we know this. Hence x average amplitude is equal to minus Vm by t into omega, it is 2 pi, into cos omega t, it is 2 pi by 2 minus cos 0. So cos pi is minus 1, minus 1, minus 1, it is minus 2, minus 2 into minus Vm, it is 2 Vm by 2 pi. Ultimately, what do we get? Vm by pi. The average amplitude of this particular signal is its peak amplitude by pi. So suppose in a class the marks of the students are varying in this fashion, then what about its average amplitude? Means highest marks of the class divided by pi. T can be anything. T may be 1 second or 1 millisecond or 1 microsecond or 10 seconds, doesn't matter, independent of the time period. What you get? Average amplitude is peak amplitude, highest marks by pi. That's it. Average amplitude is independent of the period. Time period or frequency. Okay, this is very important point. Just a basic definition. And one more thing I can write. See, I wrote 0 to t by 2 and t. Right, some people used to write it like 0 to pi and 2 pi like this. That is also valid. Means the same signal zero pi, 2 pi, 3 pi, 4 pi like this. So what is its time period? T is equal to 2 pi. Okay. X of t. It has peak amplitude of Vm. Then how do we write it here? In this case, once it is written pi, 2 pi, etc., then we write x of t is equal to Vm sin theta over the limits 0 to pi, and it is equal to 0 over the limits pi to 2 pi. Even this way also we can write. Instead of writing t by 2 t, right, we can even write like theta, where theta is varying. Theta limits are 0 to pi during the first half cycle, and during the next half cycle it is pi to 2 pi, like this. Then its average amplitude is equal to 1 by t integral 0 to t x of t dt. Now what we write, instead of t we write 2 pi, and over the limits 0 to pi it is Vm sin theta d theta we write, and from pi to 2 pi it is 0 d theta. Anyway its value is 0. I can further write it like Vm by 2 pi into integral of sin theta is minus cos theta over the limits 0 to pi, and minus Vm by 2 pi into cos pi minus cos 0. Cos pi is minus 1, again minus 1, it is minus 2 Vm minus 2 into minus 2 Vm, it is 2 Vm by 2 pi. Ultimately what we get, Vm by pi. Don't get confused with the things, friends. Okay, it may be given like 0 to, okay, t by 2 t like this, or it may be given this way, or even they may give this way also, 0 it is 5 seconds and 10 seconds. Is it necessary to worry about it? No. Okay, nothing to worry about it. However they give, ultimately the answer is, once you know the peak amplitude, then Vm or Im whatever it is, right, peak amplitude by pi, that's it. Its average value is equal to peak amplitude by pi. Blindly we can write. We need not look at the time period. Okay, these are all some basic points to observe. Done. This is right. Average amplitude means it's an imaginary line. Average marks of a particular class, right? What is the average percentage of the class? Average mark of the class. So if it is Vm, then it is Vm by pi. It's an imaginary line. That average value is also known as a DC value. Okay, why? Suppose I have a signal like this. In a class, all are having 80 marks. Then what is the average percentage? That mark itself. Very simple. So if it has an amplitude of Vm for all time, then its average value is that signal itself. Okay, it is a DC signal. No? So that's why DC signal or X average both are one and same. Average signal means average, X average means it is a straight line. Average value, it's a fixed value. So for a DC signal the amplitude is fixed. So that's why it's also it is a DC signal, and I can even equate it to average value. Its average value or its signal or both are DC component are equal. It is known as pure DC. It has no AC component. Pure DC. It has no AC component. Okay, here if you see, I can as far as the sine wave is concerned, it has both. Right, it looks like both AC and DC I mentioned, but no DC is present. Average value is 0, and hence it is pure AC. But if you take the second example, right, it has some average value. According to Fourier series, it is a combination of DC and AC. The DC or average value is given by this, or I can call this also as A0. Is it not so? Okay. A0 according to Fourier series expansion. In Fourier series language, it is A0, a constant term. In signals and systems or networks or in analog, what we take constant term means it's a DC term. Right? But AC component we can't see. DC, you can represent it, show it by means of an imaginary line, but is it possible to see the AC component? It is not possible, because we know we have to use this Fourier series expansion to find AN and BN. It has infinite number of sine and cosine terms. After adding all those signals, we can see the overall signal to be something like this. That's the meaning of it. Even this one also, right? It is a single sine wave, nothing to worry, it is a single sine wave. But here what we do, we are using infinite number of sine and cosine waves to represent this particular signal. That is, summation of all those sine and cosine terms is known as AC component. Okay, so this is one important point as far as the average value of a signal is concerned. Next, if you take this, okay, what is its average value? That signal itself. Let's say DC or average, both are same. Or if you calculate it, has no period, right? This signal has no period. So how to calculate its average value means limit t tends to infinite 1 by t integral. So what we can write, we can even write it like integral 0 to t, its amplitude is Vm, where t is tending towards infinite. We can take it, right? Or this is also taken like this. It is a DC component. X of t is pure DC term, DC signal. So how to find its average value? Here 1 by t integral 0 to t x of t dt. No doubt about it, where t is tending towards infinite. That's what I am adding. And over the interval 0 to t, what is its amplitude? Vm. So limit t tends to infinite 1 by t integral 0 to t, its amplitude is Vm dt. So limit t tends to infinite 1 by t Vm into t. I can bring this Vm outside the integration. It's a constant term. Integral 1 dt is t over the limits 0 to t. So limit t tends to infinite Vm by t into t minus 0. It is of course equal to that signal itself. Means average value is equal to DC only, x of t. The average value of a DC signal is, we need not do all these calculations, to be frank. By looking at the waveform, we can directly say that DC or average value, or right, DC and average of that DC signal are equal. Okay. This is the significance of average or DC value of a signal. And one more thing, the DC value of a signal need not be positive, it can be negative also. Suppose I have a signal like this. What is its average amplitude? Whatever may be the time period, I need not bother. Once you know the peak amplitude by pi, x average, it is also known as x DC. It is the peak amplitude is minus Vm by pi. Instead of plus Vm by pi, we can write it as minus Vm by pi. That's it. Okay. Next. Suppose I have a signal this way. What is its average amplitude? X of t. How to find it? What I do is, anyway, 0 to t by 2 t, or you can write its period is like t by 2 only. Okay, I am just writing anything, we can write it, pi, 2 pi, 3 pi, like this I am taking. What is its average amplitude? Without any calculation I am doing it, you see. We know that, anyway, just I am changing the colors for better understanding. Take this particular portion. Let me take that as x1 of t. Okay, and let us take the second one. take this as x2 of t. Then my concern is I'm just writing x1 of t. What is its average value? I can write it as a combination of DC and AC, as I mentioned, or its average amplitude. What is its average amplitude? X1 average. Its peak amplitude, if it is peak amplitude is Vm, then it is Vm by pi. Is it not so? Similarly, take the second signal. Like this. This is x2 of t. Both are looking similar with a delayed version. x2 of t is a delayed version of x1 of t. What is its average amplitude? In a class, marks are varying like this. Period is not changing and shape is also not changing. Only thing is a delayed version. Then what is its average value? x2 average. Again the peak amplitude by pi. Then we know x of t is just nothing but summation of x1 of t and x2 of t. Is it not so? Once you add x1 of t and x2 of t, we get x of t. Then what about the average value? X average. Simply x1 average plus x2 average. What is x1 average? Vm by pi plus Vm by pi. Anyway, right, x1 average is Vm by pi, x2 average is also Vm by pi. Overall, it is 2 Vm by pi. That's it. It is as simple as that. Without any calculation, just by looking at the waveform, I wrote it. You can cross-check it. Okay. So, I'm just taking the signal x of t for better understanding. So, how do we define x of t? Is equal to Vm sin omega t over the limits 0 to pi. Over one cycle I am defining. What is its period here? Its period is pi, not 2 pi. Earlier case, the period was, here the period is 2 pi. Okay, t is equal to 2 pi. Whereas here the period is only pi. Then x average, it is equal to 1 by t integral 0 to t x of t dt. Basic definition, it is 1 by pi or the interval 0 to pi. It is Vm sin theta. Let me write instead of omega t theta I am writing to make my calculations much simple. It is further written like Vm by pi integral sin theta is minus cos theta over the limits 0 to pi. Now minus Vm by pi into cos pi minus cos 0. What is your answer? 2 Vm by pi. But is it necessary to do all these calculations? Not required. Just once you understand this point, like it is looking like the two, actually this is a full wave rectifier output and this is half wave rectifier output. Adding two half wave rectifier outputs, you can see the full wave rectifier output. And once you know the average of half wave rectifier, full wave rectifier output is looking like the addition of two half wave rectifier outputs. So average values of full wave rectifier is twice the average amplitude of half wave rectifier. Like this we can write it. Okay. So this is how we can write the average amplitude of the signal.